Factor theorem. So for this video, our learning target is I can identify whether a binomial is a factor of a given polynomial. So first, what is factor theorem? So let p of x be a polynomial. If p of c is equal to 0, then x minus c is a factor of p of x, and if x minus c is a factor of p of x, then p of c is equal to 0. So basically, the concept here in factor theorem is you are going to check the remainder of the given polynomial if a given polynomial is divided by a particular polynomial or a binomial. Then if the remainder is 0, then therefore we can say, or we can conclude, that the given x minus c or divisor is considered a factor. So here is our first example. Let's say, determine whether x minus 4 is a factor of the given polynomial. So first of all, we need to consider the polynomial, which is x minus 4. So for us to check the remainder, if x minus 4 is divided from x cubed minus 2x squared minus 11x plus 12, so basically we're going to use the process that we had in our remainder theorem, wherein we are going to plug in the value of x in the given polynomial. So here, so what are we supposed to plug in? Same process, since our divisor is x minus 4, we will just equate it to 0 to find the value of x. So we will have x is equal to 4. Therefore, we are supposed to plug in or substitute 4 in our dividend or p of x. So here, we are going to change all the x into 4. And since we have here already, we were able to plug in. So next to that is we are going to evaluate the given polynomial. So following the basic rule that we have, and that is PEMDAS rule. So we are going to process first the terms with exponent. So 4 raised to 3, so we have here 4 times 4, 16, times 4, we will have 64. Next, we have 4 raised to 2, it's 16. And I'll just simply copy first the other terms here. So next to that, we're done with processing the terms with exponent, and now we are going to proceed with multiplication. So I will evaluate those terms which need to be multiplied. So negative 2 times 16, negative 32. Then negative 11 times 4, negative 44. And I'll just copy first the constant, which is 12. Next to that is, since as you can see, it's only a combination of subtraction and addition operation, therefore we can evaluate this from left to right. So 64 minus 32, we will have 32. So I'll just do it one by one. So next to that is 32 minus 44. So what's the answer? It is negative 12. And I'll just attach again the constant, the last term. So negative 12 plus 12, it will be 0. Therefore, our P of C, or our remainder, as you can see here in our solution, this one, the remainder is 0. Therefore, we can now conclude, according to the question, determine whether x minus 4 is a factor of a polynomial or not. So here in this case, we can now conclude, that therefore x minus 4 is a factor of x cubed minus 2x squared minus 11x plus 12. And that's it. You're done with the first problem. As easy as this, right? Okay, second example. Okay, so we have here, determine whether x minus 4, again, is a factor of the second given polynomial. So same process. So since it's x minus 4, therefore, we are supposed to plug in x equals positive 4. So here, okay, so we will have 2. I'll change all the x to positive 4. So we have here, and we're done plugging in the values of x. Next to that is, of course, the PEMDAS rule. So process the ones with the exponent. So 4 raised to 3. So 4 times 4 times 4, 64. Next is 4 squared, that is 16. And I'll just simply copy the next terms. I'll just do it one by one. And next to that is, after evaluating the ones with exponent greater than 1, we are going to proceed with multiplication. So the terms which we need to multiply, so we need to evaluate this time. So 2 times 64, 128. Then I'll just copy the 16 for now. So negative 2 times 4, negative 8. And I'll just copy the 15 as well. Next is, let's have 128 times 16. So we will have 144. And minus 8 minus 15. So we have here 144 minus 8. That is 136. Right? Minus 15. So we have 136 minus 15, 121. Now here, our P of C, as you can see, is 121. It is not equal to 0. Therefore, we can now conclude that x minus 4 is not a factor of 2x cubed plus x squared minus 2x minus 15. So here's our second example. It is not a factor. Okay, we're done. So next we have here, what if this is the scenario? Find k so that x plus 3 is a factor of 2x cubed plus kx squared minus 8x plus 3. So as you can see here in the problem, x minus 3 is already assumed as one of the factors of the given polynomial. Therefore, we can say that x plus 3, if x plus 3 is a factor of the given polynomial, therefore we can say that the remainder is equal to 0 already. Therefore, we can equate the given polynomial to 0. And thus, after that, of course, we are supposed to substitute the values of x coming from x plus 3, and that is negative 3. So negative 3 cube plus, of course, k, we will not change that for the meantime, and then x will be negative 3 once more, and then minus 8 times negative 3 plus 3. Okay, next to that is, of course, we are going to evaluate, and of course, we are going to process first the ones with exponent greater than 1. So we have here 2, negative 3 raised to 3, negative 27 plus k, negative 3 raised to 2, that would be positive 9, minus negative 8 times negative 3, but anyway, we are going to process this later, so I'll just do it one by one so that it is simpler for you to process if it is step by step. So next is, since we're done with evaluating the ones with the higher exponents, let's proceed with multiplication operation. So let's multiply those terms which we need to multiply. So 2 times negative 24, negative 54, plus k times 9, it's 9k. And negative 8 times negative 3, we will have positive 24, and plus 3. Next to that, of course, we need to combine similar or like terms. So I'll just set aside first the 9k here. So now negative 54 plus 24 plus 3. So I'll just copy it for a while. Negative 54 plus 24 plus 3. I'll just rearrange so that you can easily see those like terms. So copy first the one with a variable k. Negative 54 plus 24, you will have negative 30. And then I'll just copy first the 3. Next to that is negative 30 plus 3, it's negative 27, right? And then, of course, we are going to combine like term as well, which is 0 and negative 27. So we are doing the shortcut, and of course, if we are performing the shortcut, we are going to transpose the negative 27. We will have 27 plus 0 equals 9k. Next, so we will have 27 equals 9k, but we are not yet done. So continuation, so since we have 27 equals 9k, so we are supposed to find the value of k only, so we are going to divide both sides by 9, and there we will have 27 divided by 9 is 3. Therefore, our final answer here is 3. Okay, k is equal to 3. If k is equal to 3, thus we can say, thus the polynomial will be 2x cubed plus 3x squared minus 8x plus 3. And here we are done. That's it. Okay, so what about this problem? Okay, so to solve this problem, the expression ax cubed minus x squared minus bx plus 24 is exactly divisible by x squared minus 5x plus 6. So as you can see here in this case, we are supposed to find two values of numerical coefficient, and that is the numerical coefficient of the first term and numerical coefficient of the third term. So, and as you can see, our divisor is not a binomial, and instead it's a quadratic. It's a trinomial as well. So if you're going to equate it to 0, this will be quadratic equation as well. So usually we are using binomial as our divisor, but here in this case it's a trinomial. So first thing you should do is you need to factor the divisor first. So we need to factor of the factors of the divisor. So our divisor is x squared minus 5x plus 6. And if you are going to factor this, we will end up with, what do you think? X minus 3 and x minus 2, right? So x minus 3 and x minus 2, if you're going to do the FOIL method, of course, it will go back with x squared minus 5x plus 6. X times x squared, x times negative 2, negative 2x, negative 3 times x, negative 3x, and negative 3 times negative 2, positive 6. Combining like terms, you will have x squared minus 5x plus 6. It's correct. So, therefore, if the factors of the divisor is x minus 3 and x minus 2, thus the value of x here, so for you to find out the value of x, so you will just equate it to 0 and do the specific properties you are allowed to apply. So but here I know you are more particular with the shortcut, and that is you are going to transpose instead. But of course, the idea behind it's a application of addition property of equality. Ayan. See, since we do have our values of x already for our divisor, then that means we are supposed to substitute this already in our given polynomial. So here, in our given polynomial, we have a x cubed minus x squared minus bx plus 24. But of course, since our divisor is a trinomial, that means we factored it out, and there we got x equals 3 and x equals 2. So we are supposed to substitute those two values of x. So that means we need to prepare two slots or two spaces for our two solutions, of course. Here we go. So let's start with substituting positive 3s to all the x's here in our first column. So positive 3 cubed minus positive 3 squared minus b times positive 3 plus 24. And continuation of the process. So 3 raised to 3. 3 times 3, 9 times 3, 27. Minus 3 times 3, 9. And then I'll just simply copy the other term so that I can do it systematically one by one. Ayan. And here we go. So we need to multiply those terms that we really need to multiply. 8 times 27, we can write it as 27/8. And of course, I'll just simply copy the negative 9 here. Minus 9. And 3 times b, of course, we will have 3b and then 24. And as you can see, we can somehow we can combine like terms here, because we do have here like terms which are 9 and 24. So I'll just set aside first the terms which has a variable a and b, so 27a and negative 3b. So negative 9 plus 24. It's the answer. So positive 15. Here it goes. So for now, this one, take note of this. So this is our first equation. This is equation number 1. So let us just set aside this one for a while, and later on we will be using this. So let's evaluate the polynomial again with x equals 2. So a, so 2 raised to 3 minus 2 raised to 2 minus b times 2 plus 24. Next, what is 2 raised to 3? So 2 times 2, 4 times 2, 8. Then 2 raised to 2, it's 4. And I'll just simply copy the rest here of the terms. Okay, next to that, multiply the terms which we really need to multiply. 8 times 8, so 8a. Then I'll just copy the 4 for a while. Then 2 times b, negative 2b. Here, I mean negative b times 2 is negative 2b. And positive 24. So same process, we are supposed to combine like terms. So I'll just set aside for a while the ones with the variable. 8a minus 2b and negative 4 plus 24. So it's positive what? 20. So here we do have our second equation. So equation number 2. Why is it I termed it as equation? Because actually I am going to rewrite this, our answer, this one, the 27 minus 3b plus 15, I will make it into equation in the form of ax plus by equals c. So I will have 27a minus 3b equals negative 15. And then the equation 2 will be 8a minus 2b equals negative 20. So here it goes. So now take note of our two equations. We are not yet done because actually we really need to continue the process, and that is application of systems of linear equation. So let us take note first the equation that we need for our system of linear equation. So we have, because we need to have the second slide for our solution. So let's have another space for this. So here, so our equation a while ago is we have 27a minus 3b equals negative 15, and then the other one is 8a minus 2b equals negative 20. Okay, so now if you're going to apply here the elimination method, actually we cannot directly eliminate here, so we need to modify this two equations. So I will multiply this two equations. So the first equation, I will multiply it with 2. So I will multiply it with 2, and then for the second equation, I will multiply it with negative 3, so that I can have another form of equation wherein I can now eliminate one of the terms. So 2 times 27, 54a, 2 times negative 3b, we will have negative 6b, and for our constant term, so we will have negative 30. Okay, and for the second one, we will have negative 24a, and then negative or positive 6b equals positive 60. Okay, and now we can now eliminate this one of the terms. So eliminate positive 6b and negative 6b. So 54a minus 24a, we will have 30a, and then negative 30 plus 60 is positive 30. Then simply divide both sides by 30. And now we can have a equals 1. And you have your value for variable a already. And for you to find out the value of variable b, just simply use the equations that we have. You may choose either a or b. So maybe I'll be using the second equation. So 8a minus 2b equals negative 20. So just substitute the a. So 8 times a minus sorry. I cannot erase. Boy, what happened? Ayun, I'm sorry. So we will have minus 2b equals negative 20. Then negative 2b, I'll just transpose negative 20, positive 8 minus 8. So negative 2b equals negative 28. So just simply divide both sides by negative 2. And here we go. We have b equals negative 28 divided by negative 2, positive 14. And we're done. So therefore, our answer is a equals 1 and b is equal to 14. Okay, and that's it. So this will be our final answer. Okay, so that's all for this video. I hope you learn about factor theorem. So if you like this video, don't forget to click like and subscribe now. Thank you so much for watching.